About 4.5 billion kilometers away from our blue home planet is the giant planet Neptune. For many years, it was simply not possible for humans to observe the bluish-shimmering celestial body at close range. This was to change in 1989. At that time, NASA sent the space probe Voyager 2 into space, which provided mankind with the first real images of our galactic neighbor. In our contribution today, we would like to take a closer look at Neptune together with you. In doing so, we will also take a look at some breathtaking photos of the celestial body which will leave you in pure astonishment. With an equatorial diameter around 50,000 kilometers, Neptune is the fourth largest planet in our solar system. In terms of its dimensions, Neptune is 4 times larger than the Earth, whose diameter is 12,742 kilometers. The mass of the celestial body is even 17 times greater than the corresponding value of our blue home planet. In detail, Neptune is a so-called ice giant. This category includes those giant planets whose masses consist mainly of water, methane, or ammonia. In our planetary system, there are 2 such ice giants. In addition to Neptune, Uranus is also classified in the corresponding class. Contrary to the first assumption, however, the planetary surface of an ice giant is not necessarily frozen. In fact, the corresponding substances are present as so-called supercritical fluids. That is to say, they are in a special state of aggregation in which the properties of liquids and gases are combined. The existence of Neptune has been suspected since the early 17th century. Among others, the famous Italian scholar Galileo Galilei succeeded in identifying the planet in the firmament between 1612 and 1613. However, the existence of Neptune was not officially confirmed until 1846 when various calculations and observations scientifically substantiated the existence of the distant planet. Incidentally, the name of the celestial body comes from Roman mythology. In the stories of the ancient Romans, Neptune was considered the ruler of the oceans. In view of the characteristic blue coloring of the planet, which is visually reminiscent of water, the choice of name was extremely appropriate. The surface coloration of the celestial body is not caused by a rich water supply but in reality by large amounts of methane. Neptune does not orbit around the Sun alone but enjoys the galactic company of at least 14 moons. The largest of all Neptune's moons is Triton, which has an equatorial diameter of about 2,700 kilometers. The natural satellite of our blue home planet is slightly larger than Triton, with a diameter of about 3,474 kilometers. Interestingly, it was long suspected within the research community that the dwarf planet Pluto is a former moon of Neptune. Later investigations, however, led to the conclusion that this thesis does not correspond to the truth. If you decide to search for Neptune with the naked eye in the starry sky on a clear night, you'll unfortunately have bad luck. This is because the ice giant is the only planet in our solar system that cannot be seen in the firmament without technical aids. At a distance of about 4.5 billion kilometers, Neptune orbits around the Sun. The orbit of the celestial body describes an almost complete circle. While the Earth only needs 365 days to orbit the fixed star of our planetary system completely, Neptune requires a much longer period of time for orbiting the Sun. It takes almost 165 years before the ice giant has completely orbited the Sun. The days on Neptune are again substantially shorter than on our Earth. Neptune only needs about 16 hours to rotate once around itself. Just like on our blue home planet, Neptune also has different seasons. While autumn, winter, and the others on Earth last only a few months each, the individual periods on Neptune extend over a period of more than 40 years. Because Neptune is separated from the Sun by such a huge distance, the intensity of solar radiation on the planet is also relatively weak. This fact has a direct effect on the temperatures that prevail on the surface of the ice giant. Thus, the thermometer on Neptune never exceeds the value of -201 degrees Celsius. Due to its material composition, Neptune also has no clearly defined atmosphere. In all probability, however, the planet has a solid, quite large core which is approximately the size of our Earth. While it's freezing cold in the outer regions of Neptune, temperatures of up to 7,000 degrees Celsius prevail around the planet's core. In the late 1970s, NASA sent the unmanned spacecraft Voyager 2 into space to study the composition of various planets in our solar system more closely. After the spacecraft had already collected important information about Jupiter and Saturn, it finally reached the immediate vicinity of Neptune in 1989. As mentioned at the beginning, Voyager 2 succeeded in taking the first real photos of the giant planet, showing the celestial body in all its galactic splendor. During the mission, the planet's rings were discovered for the first time, and 9 previously unknown moons of the planet were also discovered. But also, the investigation of the already known and largest Neptune moon, Triton, was an important goal of the mission. It was determined that numerous geysers rage on the surface of the moon, ejecting liquid nitrogen in large quantities. If you thought that Voyager 2 would stop its service after passing Neptune, you were wrong. In fact, the spacecraft, which left Earth on August 20, 1977, is still orbiting through the endless expanses of space, providing scientists on our blue home planet with important data. In the course of its mission, Voyager 2 produced numerous images of the planet Neptune, which were later supplemented by images from modern telescopes. Some of the official photos show the breathtaking rings of Neptune. In these photos, the 2 main rings that orbit the planet can be seen particularly well. The ring system of Neptune is very different from its counterpart in the immediate vicinity of the planet Saturn. While Saturn is surrounded by hundreds of thousands of rings that together form a complex system, the ring system around Neptune consists of very fine and significantly fewer orbits. The individual Neptune rings are relatively dark and consist mainly of microscopic dust particles. Experts suspect that these galactic dust accumulations are the remnants of various meteorite impacts on the surrounding moons. In a photo taken by the Hubble Space Telescope, we recognize the small moon Hippocamp. In detail, it is the smallest of all of Neptune's moons. This natural satellite of the ice giant was discovered in 2013. When Voyager 2 passed the vicinity of Neptune, it could not discover Hippocamp due to its limited technical capabilities. Since the moon is not only extremely small but also quite dark, it was missed. On the images published by NASA, we can also see the moons Thalassa, Galatea, Despina, and Larissa. Some more photos show Neptune in its full splendor. In these photos, we not only see the characteristic blue coloration of the celestial body but can also make out numerous details on the surface of the ice giant. We can recognize large cloud formations that cast clearly visible shadows. Scientists suspect that the clouds on Neptune are largely made up of methane gas. The fact that the appearance of Neptune can vary considerably depending on the angle of the view and the season is shown in photos that depict the giant planet and its moon Triton as sickle-shaped formations. The moon Triton was also closely examined by NASA's highly complex equipment. The surface of the natural satellite is adorned by numerous geysers, and some craters from meteorite impacts are also clearly visible. Triton, Neptune's largest moon, is one of the most intriguing objects in our solar system, with its dynamic and changing surface. The moon Nereid is the third largest natural satellite of Neptune. Nereid was first discovered in 1949 by the astronomer Gerard Peter Kuiper. Nereid was the last moon discovered before Voyager 2 set off in the direction of Neptune and was able to locate several other natural satellites of the giant planet. The space probe of the renowned space agency finally delivered the first images of the Neptune moon, which was named after sea nymphs from Greek mythology. If we look at the photos of the moon Proteus, we quickly realize how diverse the natural satellites of Neptune are in terms of their shape and composition. While many of the moons in our planetary system appear to be spherical in shape, Proteus breaks up the familiar pattern with its unusual shape. The existence of the moon, whose name is also borrowed from Greek mythology, was completely unknown to mankind until NASA's Voyager 2 mission. Neptune's magnetic field is another fascinating aspect of the ice giant. Unlike Earth's magnetic field, which is relatively aligned with the planet's rotational axis, Neptune's magnetic field is highly tilted, about 47 degrees off its axis. Additionally, the magnetic field is offset from the planet's center, which suggests that it may be generated closer to the planet's surface rather than deep within its core. This unusual magnetic field creates a complex and dynamic magnetosphere, which affects how charged particles from the solar wind interact with the planet. One of the most remarkable features of Neptune is its powerful atmospheric storms. The most famous of these is the Great Dark Spot, a massive storm system similar to Jupiter's Great Red Spot. Discovered by Voyager 2 in 1989, the Great Dark Spot was as large as the Earth and had wind speeds reaching up to 2,400 km per hour, the fastest recorded in the solar system. However, when the Hubble Space Telescope observed Neptune a few years later, the Great Dark Spot had disappeared, illustrating the dynamic and ever-changing nature of Neptune's atmosphere. New storm systems have since been observed, showing that Neptune's atmosphere remains highly active. Neptune plays a crucial role in shaping the structure of the Kuiper Belt, a region of the solar system beyond Neptune's orbit filled with small icy bodies. The gravitational influence of Neptune has a significant impact on the orbits of many of these objects. Some Kuiper Belt objects, KBOs, are in a resonant orbit with Neptune, meaning they complete a certain number of orbits around the Sun for every orbit Neptune completes. For example, Pluto, which is one of the most famous KBOs, is in a 2:3 resonance with Neptune, completing 2 orbits around the Sun for every 3 orbits of Neptune. Neptune's gravity can also scatter KBOs into more distant and eccentric orbits, contributing to the formation of the scattered disk, a distant and less densely populated part of the Kuiper Belt. This interaction underscores Neptune's influence far beyond its own orbit, shaping the outer regions of our solar system. Understanding these interactions helps scientists learn more about the dynamics of planetary systems and the distribution of small bodies in space. In summary, Neptune is a planet full of wonders, from its fierce storms and unique magnetic field to its influence on the Kuiper Belt. Thanks to missions like Voyager 2, we've gained incredible insights into this distant ice giant, but many mysteries remain. If you enjoyed this exploration, please give us a thumbs up, subscribe to Space Lab, and stay tuned for more cosmic discoveries. Thanks for watching, and see you next time.